Hi and Assalamualaikum. So today we will learn about chapter 5, which is integration. Let's see, these are the subtopics covered in this chapter. The first one is what is integration. The second one is basic rules of integration. The third one is the integral of exponent x, a to the power of x, and exponent ax plus b. And the fourth one is the integral of 1 over x, which is a fraction, and the integral of 1 over ax plus b, where ax plus b is a function. Okay, for the first subtopic 5.1, integration, we will start with a given y equal to a function fx. So let's recall, if we differentiate both sides with respect to x, we will get dy over dx equal to f prime x. If you differentiate this, so you will get this. Then, when we integrate both sides with respect to x, what happens is you will have this sign. This sign is actually the integration sign. Integrate dy dx. This is the one, dy dx. And you have extra dx over here. You need, when you perform integration, you have to put this sign and dx at the back. So you have integration of dy dx, dx equal to, write it down again, integration of f prime x dx. So this is how you write down your integration. So what you will get after you write down this one is y equal to integration of f prime x dx. Why do we get y over here? Is because dx and dx over here you can cancel out. So you integrate dy, so you will get y, only y. And this is known as indefinite integral. And y is fx plus c, where c is a constant. So can you see both methods over here, the differentiation and integration? It's actually vice versa, terbalik, berlawanan. So in differentiation, if we differentiate this one, you will get this. But when you integrate this part, again you will get this. Okay. So integration is actually the process of finding antiderivative, is called an antidifferentiation or integration. So this is what is integration, the process of finding antiderivative. Or other definition is a function f is called an antiderivative of a function f if the derivative of f is f. So we have to refer back to the previous slide. So this is what does it mean by the definition. So this is subtopic 5.2. Basic rules used in integration. The first one is when you integrate k dx, you will get kx plus c, where k is a constant and c is an arbitrary constant. So you have k over here is a constant. When you integrate, you will have kx plus c, where c we don't know, the constant might be 1, 2, 3, and so on. So this is the example. Integrate 2 dx equal to 2x plus c. So all you have to do in integration is you just need to add x at the end. I see. Integrate 2 dx, you will get 2x plus c. Don't forget your constant over here. So if we recall back when we perform differentiation, if let's say we want to differentiate 2x over here, you differentiate 2x, you will get 2. See? It's actually kind of back to back. dia terbalik saja, dia patah balik. Okay, so you differentiate 2x, you get 2. But now you integrate 2, you get 2x. So in integration, you just need to plus the x. You just need to add up the x over here. So this is the very basic rules for integration. Hopefully you can get it. Okay, the second rule is when you integrate x to the power of n dx. So what happened here is equal to x to the power of n plus 1 divided by n plus 1 plus c. So all you can see over here is that you need to plus 1. When you perform differentiation, you need to minus 1, right? The power you have to minus 1. Tolak 1 bila kita perform differentiation. But when we perform integration, you have to plus 1, the power. So here, originally you have x to the power of n. When you integrate, you will have x to the power of n plus 1. N plus 1 divide by this new power, n plus 1. And don't forget to put your c, your constant. So let's see the example. Integration of x squared dx. So when you have to integrate this, remember you have to plus 1 the power. So you will get x to the power 2 plus 1. And again, this new power you will divide. X to the power 2 plus 1 divide the new power, which is 2 plus 1. Plus c. Then you have x to the power of 3 divided by 3 plus c. So just let it as c, since we don't know what is the constant value. So just put it as c. Okay. So you have learned about the first basic rule, and the second one, when you have power, you just need to add 1 to the power and divide it with the new power. Okay, rules 1 and 2 can be summarized as integration of kx to the power of n dx equal to k integration of x to the power of n dx, where n must not be equal to negative 1. Remember, the power over here should not equal to negative 1. And when you have k over here, k is a constant. Let's say 2, 1, 3, and so on. You can take it at the front, put it at the front. Okay, so the remain here is only x. So it's easier for you to integrate. So back to here, k we just write down is as k, because when you differentiate, you don't need to differentiate this k, you just write it down, but you have to differentiate this x. So again, when you differentiate x to the power of n, you will get xn plus 1 divided by n plus 1 plus c, the arbitrary constant. Okay, notes here. Okay, when n equal to 0, we have integration of k dx equal to kx plus c. Okay, mana dia cakap, when you have your power n is equal to 0, so all you have is only x to the power of 0 will be 1. So all you have is integration of k dx. So when you integrate k dx, remember when you integrate constant, you have to put x over here. So kx plus c. Okay. Next, the third one, integrate k, a constant, fx dx. So remember, when you have k, constant, you just write, or you need to put the constant at the front. So the remaining will be the one with x. So you have function x dx. So let's see the example over here. You can see integrate 4 over set x dx. So what is the constant over here? So the constant will be 4. So you put the 4 at the front, so the remaining will be the set x. Or the set x, we can write it down as x to the power of negative 1 over 2. Why do you have negative? Because it is 1 over set x. So when you have 1 over set x, there will be a negative 1 over 2x. Sorry, x to the power of negative 1 over 2 dx. So all you need to do is you integrate this one. The 4 is remain 4 at the outside. So together, let's do this. Integrate x to the power of negative 1 over 2. So remember, when you have power, you need to plus 1. X to the power negative 1 over 2 plus 1. And then you divide it with the whole new power over here. So you divide it with negative 1 over 2 plus 1. And remember to put your arbitrary constant plus c over here. So you have that when you simplify this, 4 times this whole thing, you will get 8x to the power of 1 over 2 plus c. And x to the power of 1 over 2 is actually equal to set x. So you will get 8 set x plus c. Okay, continue with rules number 4. When you have to integrate a function fx plus or minus function gx dx. So in here you have to integrate both functions. So what you have to do is we separate or we split up the two functions just now. So you have integration of fx dx plus or minus integration of gx dx. So for example, you have to integrate x plus x squared dx. So the first function will be x and the second function is x squared. So now we write it down back. Integration of x dx plus integration of x squared dx. So when we integrate x, remember x to the power of 1, right? So you have to plus 1 the power. So you will get x squared. And don't forget to divide the new power over here. So x squared divided by 2 plus differentiation of x squared. So you have 2 over here, you plus 1. So you get x cubed minus, x cubed divided by 3 and plus c. Always put plus c at the end of your answer. Okay, so quotient number 1. When we integrate two functions, the multiplication of two functions, fx gx dx is not equal to integration of fx dx multiply integration of gx dx. So this one you cannot do this. You cannot split it up like this. Only for plus or minus, then you can separate it or split it. Okay, the second one you have to be cautious about when you have integration of fx gx dx is not equal to function fx integration of gx dx. This is also wrong. You cannot do that. And number 3, integration of fx divided by gx dx is not equal to integration of fx dx divided by integration of gx dx. So this is also wrong. So remember, for both functions, you can only separate it or if there is plus or minus sign like the previous one, like this. Okay? only like this, plus or minus, then you can separate it or pecahkan dia. Okay. Now, let's see example 1. Evaluate the following integrals. So, A, integrate 1 over x cubed dx. And B, integrate set x dx. Okay, let's see how we're going to solve it. The first one, integrate 1 over x cubed dx. So remember, x cubed 1 over means there will be a negative 1 over. So we write it down back, integration of x to the power of negative 3. Why negative? Because it is 1 over. So it becomes x to the power of negative 3 dx equal to, when we integrate this one, remember you have to plus 1 this power. So you will have x to the power of negative 3 plus 1 divided by negative 3 plus 1. This is the new power. Plus c. So you will have negative 1 over 2x squared plus c. Because why do you have negative 1 over 2 over here? Because when you simplify this one, x to the power of negative 3 plus 1, you will get x to the power of negative 2, right? So when x to the power of negative 2, it's actually equal to 1 over x to the power of 2. 1 over. So over here you have negative 3 plus 1, so you get 2. That's why you get negative 2 over here. And plus c. And remember here you have n equal to negative 3. So your n is actually equal to negative 3. Here, this one. This one. This is your n, right? In this case, your n is negative 3. The power. Okay, for B, integrate set x dx. So remember, set x is actually equal to x to the power of half dx. So when we integrate this part, you will get x half plus 1. And then don't forget to divide it with the new power. So you have divide 1 over 2 plus 1 plus c, and you simplify this thing. So you will get 2 over 3 x to the power of 3 over 2 plus c. Remember, in your exam, please simplify the answer, okay? And then after this, you will get 2 over 3. You just write it back, 2 over 3. Here, how do you get set x 3 over here? Because x to the power 3 over 2, remember x to the power of 1 over 2 is actually set, right? Set. So we have 1 over 2 over here. From here, 1 over 2, set x. Then the times 3. So that's why you have to the power of 3 here. Okay? Plus c. So in this case, our n is actually 1 over 2 from here. Okay, next example. Evaluate the following integrals. A, integrate 4 over set x dx. B, integrate 3x to the power of half dx. C, integrate 1 over 2 x to the power of 3 dx. And D, integrate 70 to the power of 3 over 4 dt. So it's quite unusual, right, for the question D, because we usually use x, and suddenly question D you have t. It's actually the same with the 3 of these questions, only that the variable at the end, they don't use x, they use t. Sometimes they use s, h. Okay, it's the same. So solution. Integration of 4 divide by set x dx. So remember, when you have constant, you place it at the front. So 4 is your constant, so you place it at the front over here. The remaining will be 1 over set x. 1 over set x means that 1 over means you will have negative, right? Anything yang kita ada 1 per, so you will have negative. And 1 over 2 is because of the set. Macam mana dapat 1 over 2? Because of the set. Okay. So, all you need to do is you're going to integrate this one. So, 4 will be remain here. 4. You integrate x to the power of negative half. You will get x to the power of negative half plus 1. So, remember, integration is always plus 1. Okay. When you integrate, you have to plus 1. Again, you divide it by the new n. I mean the new power over here. So you integrate, divide it with negative half plus 1. And then forget to plus c. So you expand this one and you will get 8x to the power of half plus c. Again, don't forget to change the x half over here. X to the power of half is actually equal to set x plus c. That's it. And let's see question B. Integrate 3x to the power of half dx. Okay, so you remember you have 3 as the constant, so you place the 3 at the front. Jangan kacau dia, letakkan dekat depan. So now you have to integrate x to the power of half dx. Okay, so 3 at the front. Now you have to integrate x to the power of half. Then you will get x to the power of half plus 1. Divide by the new power, 1 over 2 plus 1 plus c. Okay. So at the end, when you simplify it, you will get 2x to the power of 3 over 2 plus c. Okay. Okay, let's see over here. C, integration of 1 over 2x cubed dx. Okay, now what is your constant? So we can take out your constant, which is 1 over 2, right? So 1 over 2, you place it at the front. Then integrate the remaining, which is 1 over x cubed. 1 over x cubed just now will be x to the power of negative 3, because we changed it already. Since it is 1 over x cubed, so it becomes negative x to the power of negative 3 dx. So now you have to integrate this part. So it's easy, right? When you integrate x to the power of negative 3, you have x to the power of negative 3 plus 1. And then you divide it with the new power, negative 3 plus 1. Okay, so sorry, this one I forgot to plus c over here. So you should plus c at the back, okay? Don't forget to plus c at the back. And then you simplify it, then you get this answer, okay? And plus c. Sorry, I forgot to write. I forgot to plus c. Let me draw it for you. Plus c. And this one also plus c. And this is 1 over 2, so the remaining will be 1 over x cubed, right? Just now, 1 over x cubed is actually equal to x to the power of negative 3. That's why you get this part. Okay, this is from here. Because 1 over 2 you dah bawa keluar. Okay. So the last one, integrate 7t to the power of 3 over 4 dt. Okay, so 7 is your constant, so you're going to place it at the front, 7, and then you have to integrate the remaining one, which is t to the power of 3 over 4 dt. Why is it dt? Because in here you have t. So of course you will have dt. Let's say when you have when you have s, so that will become ds. When you have x, so it will become dx. Okay, like that. Okay, so 7, it still remain here 7, so you just integrate this one, t to the power of 3 over 4 plus 1, divide by this. Okay, so you get this, and plus c over here. So you simplified it, then you get this answer. Okay, so this is example 3. We're going to see lots of examples so that you can understand better. Okay, evaluate the following integrals. A, integrate x plus x squared dx. So remember, you have two functions over here, x and x squared. And how about this? B, integrate 3x squared minus 2x squared plus 7x plus 5 dx. So a bit longer than the A. And then C, you will have integrate 7 over y to the power of 3 over 4 minus, not square root, this one is cubic, y plus 4 times square root of y dy, and the square root of a fraction over here, dx. Okay, let's see one by one. Solution. Okay, remember when you have two functions, let's say this is fx, this is gx. Function number 1, we're going to split it since you have plus over here. Remember, you can split the function into 2 when you have plus or minus. So we have integration of x dx, the first one, x dx, and integration of the second one, x squared dx. So plus, just write it down as plus. So now integrate x, you get x squared over 2, plus integrate x squared, you get x cubed over 3, plus c. Okay, done. Then we move on to question B. Integrate 3x to the power of 6. This is polynomial. You can see the pattern of the power, 6, 2, 1. Okay, so 3x to the power of 6 minus 2x squared plus 7x plus 5 dx. So in here we can split it one by one. Boleh pecahkan satu-satu. So you have this one, 1, 2, 3, and 4. So you have 4 integration. Okay, the first one you have 3. 3 is a constant, so you just let 3 over here. Then you have x squared dx. So this will be your first function, and then minus, so I just write it on minus. 2 is your constant, put 2 at the front, then the remaining will be x squared dx. Okay, that is number 2. And then the third one is 7x. Again, 7 is your constant, put it at the front, so you will have to integrate only x dx. And last, you have 5. So integration of 5 dx. You can't just put it at the front since there will be no remaining. So it's okay to put it in here, okay, even though it is a constant. Okay, now let's see how we solve the integration. 3 remaining 3, so x to the power of 6 become x to the power of 7 divided by 7. Then minus 2 remain 2. Integrate x squared, you get x cubed over 3 plus 7, this one 7, remain 7. Integrate x, you get x squared over 2 plus integrate 5. Again, when you integrate constant, you will have 5x plus c. Okay. Next is integration of, it's a big, this one is a mixture of fraction, and then you have third, okay. So don't worry, we're going to solve it one by one. Integrate 7 over y to the power of 3 over 4. So for the first part, we're going to split it into 3. Okay, this one is number 1. This is number 1. This is number 2. This is number 3. You're going to solve it one by one. So again, what is your constant over here? 7. So 7 is a constant, you put it at the front. So the remaining ataupun baki-baki dia, you have 1 over y 3 over negative 3 to the power of 4. Since 7 you dah letak dekat depan, so yang baki dia cuma tinggal ini kan? Y to the power of 3 over 4. So this part actually equal to yang ini. Dia equal to yang ini. Dia 1 over 3 to the power of 4. So bila kita tulis balik, it become y to the power of negative 3 over 4. Negative mean 1 over. Okay. Then we have the second part, minus. Since you don't have any constant over here, so we just write it down again. Integration of y to the power of 1 over 3. How does it become y over 3? How does it become this part? Yang ni, kenapa boleh jadi macam ni? Because when you have set, let's say set y is actually equal to y to the power of 1 over 2. Kalau kita ada set, not set, punca kuasa 3y, so 3 ya. So it will become y to the power of 1 over 3. Dia samalah formula dia macam ni. Kalau set y, dia jadi y over y to the power of half. Kalau punca kuasa 3, dia jadi macam ni. Okay. This is this. Then you have plus 4. Okay, so 4 is a constant, so kita letakkan dekat depan. Then you have to integrate set y. So again, set y kan, yang ni, this part ni adalah yang ini. Set y ni bersamaan dengan y to the power of half. That's why dia dapat this part. So now you can integrate 7, integrate y to the power of negative 3 over 4, you plus lah, tambahkan dengan 1. Tambah dia dengan 1 ni, tambah 1. So dapatlah ni, divide by y over 1 over 4. Sama juga yang ni, y to the power of over 3, bila you integrate, dia plus, kita plus 1. So dapat yang ini. Okay. Dan last kali y to the power of half, kenapa jadi macam ni? Because you plus 1. Half ni, you plus 1. Half ni, you plus 1. Then you get this. Then you get this one. Sorry, it's a bit messy. Okay. And yang bawah-bawah ni, macam mana dia dapat? Sebab we divide again with the new power. Okay, see, tengok yang power atas ni sama dengan yang hasil bahagi kat bawah. Okay, then you can simplify your answer. Itu sajalah. Okay, so that you can get this one. Okay, next question D. Integrate x to the power of 5 plus 2x squared minus 1. Divide by x to the power of 4. So now you have division, hasil bahagi untuk this function. So untuk senang, you better divide it with x to the power of 4. Let's say you have x to the power of 5. So you divide by x to the power of 5. This one, x to the power of 5 divide by x to the power of 4. 5 bagi 4. Maksudnya tinggal 1x to the power of 1. That's why dia dapat ni. Okay, then again, 2x. You have 2x square minus x to the power of 4. Okay. So, macam mana kita mau bahagi dia? So, 2 ni remain. X ni akan jadi 2x 2 minus 4. Dia jadi macam tu. Okay, so you will get 2x negative 2. Okay, sorry. My handwriting is not so good when you are using mouse, not using a pen. So you get this part. Okay. Itu kalau bahagi x square divide by x4. So kalau hasil bahagi, kita tolakkan dia. So you have 2x to the power of negative 2. Itu adalah yang ini. So 2 adalah constant, so you place it at the front, siap-siap. And the last one is negative 1 over x4. Okay. Negative, the last one. This one. Negative, negative, because it's minus over here. So you have 1 over x to the power of 4. Ini adalah equal to x to the power of negative 4. Ingat, kalau kita ada 1 over, dia akan jadi negative 4. Sebab dia 1 over. That's why dia dapat yang ini. Okay, so again, you just integrate it. Normally, integrate x, you get x square over 2 minus, why is it become minus? Because dekat sini ada ni. So, integrate x negative 2, you get x to the power of negative 2 ni, dia akan plus 1 lah. So, dia become x to the power of negative 1. X to the power of negative 1, ini kan akan, bila kamu integrate, dia akan dapat jadi x to the power of negative 2 plus 1. So, it become x to the power of negative 1, kan? Jadinya, x to the power of negative 1 sama juga dengan 1 over x. That's why lah dia dapat yang ini, 1 over x. 2 tu dapat dari mana? 2 tu from here. Yang ni. Okay. Okay, next. Oh, sorry. It should be plus over here. I'm sorry. It should be plus. Okay. Betul lah. Dia negatif. Kenapa negatif? Why is it negative over here? Because when you integrate this one kan, you have to divide by negative 2 plus 1. So, yang di bawah ni kan hasil dia negatif. You get this one negative 1. That's why dia ada negatif dekat sini. Then juga this one, x to the power, integrate x to the power of negative 4, you will get x to the power of negative 3 divide by 3 plus c. Okay, that's it. All the 4 questions solved. Okay, let's see another example. Find the antiderivative fx of fx equal to this one. Punca kuasa 3 bagi x. That satisfies f1 equal to 2. So what does it mean by antiderivative? Over here, antiderivative mean integration. Maksudnya, kita kena cari integration of this function. Okay, first, you have fx equal to integration of this part, dx, which is actually you can write it again in this form, since it has punca kuasa 3, so you have x to the power of 1 over 3. Remember just now, kalau kita ada square root, when we have square root of x, so you will have x to the power of 1 over 2. When you have punca kuasa 3, so you will get x kuasa 1 over 3. Macam tu. So, this one you can integrate x to the power of 1 over 3 plus 1 over, divide lah, bagikan dengan yang tadi tu. So, now you get this answer. And then, dia kata that satisfies f1 equal to 2. So, we substitute f1, the x value with 1. So, now you have this answer, right? you're going to substitute the 1 over here into this function. So you equal it with 2. Sebab dia kata yang ni. Dia dah bagi syarat dia. So that you can get the C, the arbitrary constant. This is arbitrary constant, C. C equal to 5 over 4. Ni dia pindah-pindahkan lah. C remain dekat sini. The rest 3 over 4 bawa pindah ke sebelah. So it become minus 3 over 4. So you get your C constant. Previously we only have C plus C plus C plus C. We don't know the value of C. So now for this question, you have the chance to obtain the C value because there is a condition given over here. So you can find the C. If there is no condition, then given, then you don't have to find the C. Just write it down normally as C lah. Okay, then you can write it back. Yang ni tadi kan kita boleh tulis balik. Fx equal to 3x to the power of 3 over 4. Yang ni tulis balik plus 5 over 4. Itu sajalah. Oh, sorry. It should be 4 over 3, yeah? Oh, sorry. This one should follow this. Okay. It should be 4 over 3. 4 over 3. Okay. So you get this. Okay. This is your C. Okay, this you might want to try the exercises. So I have 3 questions. With the answers given, you can try it on your own before we proceed to the next subtopic.